better. Hello, everybody. Good to see a few of you out there. So, welcome. Thanks for joining me for the live stream. That's always helpful to ask questions and answer questions. So, thanks for being here. And also, I have the backup for if my audio is not working, which I did on Monday morning. So, hopefully, not this time. So, welcome. We are starting the fourth week of the semester, and we have 17 weeks. So, you can kind of rough that in as we're almost a quarter of the way through the semester. Oh, that's cool. I'm glad, Soren. I mean, I'm not glad, Soren, that your class got canceled, but I'm glad you could be here with us for the live stream. So that's good news for me, anyway. Um, so I'm glad to have you here. Okay, so we're about a quarter of the way through the semester. Um, oh, two of you had that, maybe same class as well. So welcome. I'm glad you guys could make it, and sorry that you can't every time. Okay, so where we're at, the project. I need to not forget to talk about the project today. We have talked about it, and we've done some setup, but we'll go revisit the starter that I made for myself, and look at what new parts of the project we can solve. The answer is, by the way, after today, you can do everything that the project requires of you. And its due date is coming up. It's this week, isn't it? It's coming up soon. Somebody has already submitted one, so that's good news. And hopefully we'll start to see more of you stream in your projects sooner than later. Okay. What was I going to do today? Oh, I was going to start by demoing some of your work. Let's see if I can do this. Can I? I can. So let's look at some of the work that you guys did on the lab last week, because some of you have taken advantage of the opportunity to be just a little creative and done that. So that's quite. Oh wait, you may not be able to see it that way. Can you see it that way? Let's just leave it like this, because I know you can see that. So here's a person who added in the little sequence with the name in it, which is a nice touch. So this wasn't a requirement, but it did say at the bottom that you could add extra outputs if you wanted to. And then here they've used my name to build their prompts, which was awesome. We may have shown a brief example of that in lecture in the last week or two. But anyway, this is quite cool. Today's Tuesday. In September. We're 13 days into September of the year. So I'll just kind of, what I'm seeing here, they used my name, which was very cool. And also notice that this person has introduced some blank lines in their output, so that the sections are grouped together. So we have the 4 inputs for the date, space, an output with my name in it again, which is cool. What city? I could be wherever I want to be, can't I? I will be in Dallas. I don't know. And then I did this little test on everybody. So I did 3 decimal places of input, and the output should be 2 decimal places, which it was. There's my name again. So nice job. That's a very, very cool one. Copy link. And I've got 5, so I'll just run through these real quick and kind of show off what they did. So you don't always have much room to kind of play with, but when you do, it's fun. So this person was clever in that they made their prompts include the expected kinds of inputs. So notice they didn't just say enter in the current day of the week, but they also said, for example, one of these Sunday through Saturdays. Today's Tuesday. Same for the month. Can I move this around? I can't, so it's fine. 13th. Anyway, so clever use of the prompts, right? To provide the additional guidance for the person typing at the keyboard, what kind of information is expected. Let's go to El Paso. Oh, that's my fault. That's my bad. some of you experience this, by the way. We are not in a position where we can handle spaces in our input. So L space passo, it's expected that that would break. So that's not a big deal. I'll just smush it together. That's what I expected to happen. So anyway, very nice prompts on that one. I thought that person was clever about creating prompts that provide the user with extra guidance, which is always a good thing. Oops. So this one, that's my spelling, not their spelling problem. San Antonio. So this one is just an example of sort of just a very straightforward lab, but notice the blank lines in the outputs that group things together. So the best labs did that, right? They didn't just mush everything together. They actually took the time to kind of think about their outputs, and then they added some extra blank lines to make them look prettier, which I notice because it makes your work stand out. So nice job on that. 4 of 5. This one has a welcome message in it. So this one also takes the name. Tuesday, September. Sorry, itch. We go to Austin. And then there's this little follow-up message at the end because, again, it was optional. You could add extra outputs. And if you notice at the very end, my name comes back. So that's cool. I gathered my name at the very beginning, and then they referred back to it in that last output, which I enjoyed. And then one more just so you can see just some of your classmates' work. This one I thought the prompts were cleverly done. So it's on the next line down, but there's a little dash, and that just looks just so much better that way. Look how much better it looks just with that little dash and a space there. It makes this work look professional, which is great. So I like that a lot. That looks really, really good. And then the spacing, in the Galveston, let's see. So anyway, just a couple of examples and the places where people found that they could kind of personalize the result of their lab and do some nice things like some different kinds of prompts. I think one person, by the way, only one person out of almost 60 people didn't know what a prompt is. So that's very, very good. That means that everybody but that one person is paying attention, which is quite good. So anyway, good work on the labs this week. And most weeks, next week, if hopefully I will have graded the projects by the time I see you again, and we can look at those. I think that's next week. Anyway, it is this Sunday. So most weeks I'll try to demo you, do some demos for you so you can see your classmates' work. Okay, so let's look and see what we got going on this week by walking through the module. So we're doing arithmetic operators. So that just means how do you make a computer program perform math, addition, subtraction, multiplication, and division. And then the one special one, which I suspect most of you, because this is a very kind of computer science thing, most of you have probably never dealt with the concept of modulo, which is what the little percent symbol you see in the agenda is. Let me move the agenda. So on line 17 here, there's a little percent sign. We call that the mod operator or modulo. And it's a super useful operator for doing a particular kind of arithmetic in computer programming. So we'll talk about it and what you use it for. So let's walk through the module and then we will look at some code samples, look at how these operators work, talk about what is an operator, and so on. Okay, so we're going to do whole number arithmetic, which means integers. So this is one of the more challenging aspects of doing arithmetic in a computer program, is that whole number arithmetic is different in some ways from floating point arithmetic. 1 divided by 4 integers is not the same thing as 1.0 divided by 4.0 in floats. And it takes some time to get used to that fact. It's very useful that that's true. We use that reality a lot in our programming because there are a lot of clever solutions you can create for problems if you understand that whole numbers do math in programming different from floating point numbers. And then in particular, and it's for our project, but also because I just think everyone should understand how these work well, we'll talk about the difference between division and modulo on integers and how you use them, what they mean. Because a lot of us are in the habit, I think, of doing math without thinking about what the math means. You know what it means to add to a quantity because the quantity gets bigger or more of it, and subtracting from a quantity makes less of the quantity, and multiplying a quantity creates some set of multiples of it. But then division and modulo, I think a lot of people, especially when you need to use them to solve problems, forget what they mean, kind of. So we'll talk about that today. And hopefully kind of refresh your memory about what they mean, what their purpose is. Okay, so readings, there's not a whole lot, and you guys are doing a good job in Piazza discussion, finding resources. So there's been a lot. If you go back to Piazza, and if you haven't, your classmates have collected all kinds of videos, all kinds of tutorial sites, different web-based books in Go programming. Some people found podcasts about Go programming. There's a lot of extra resources out there. And the reason why you want to consume those and find learning resources that supplement what you do in any class you ever take is because sometimes the way a different person explains the way something works makes more sense to you more quickly than some other person trying to explain it. So I'm one person. I try as much as I can to explain it in a variety of ways based on my own experience, but I'm not going to get all of the ways to explain things. So that's why those extra resources are helpful. And these readings, I do write my questions out of them, so I do ask you to do these readings, but I'm also hoping that you're finding among these readings or other resources things that are useful to you. Homework, which is a way to sort of prepare you for the week's work by having you do reading and answer questions. The lab, let's see. I'll come back to I'm going to come back to the lab after I get through the whole module. Okay, so the discussion is all about this modulo operator. So I've given you some readings to follow up on. But this modulo thing, for whatever reason, is just the most awkward to all of us. The moment that you understand how modulo works is just one of those breakthrough moments. You have this new power to solve problems that you didn't have before. So the discussion will ask us all to do some more reading and then continue talking about and thinking about this modulo operator and what it is, how it works, what it can be used for, that kind of stuff. The project is due on Sunday. I don't know why I clicked that like that. The project's due on Sunday. It's not something that you should wait till Sunday night for. So unfortunately, I'm saying this to some people who will be, if they watch the lecture at all, will be watching it on Sunday night. And all I can say is I'm sorry you waited until Sunday night, because projects are bigger than labs, which is why there are more points, which is why they're announced several weeks in advance. And I hope that you do well and don't get too stressed over it. So for those of you who are here now for the live stream and watching the video earlier in the week, you want to get in there and get started on this thing. You need to find and make time to do it. You may find that you knock it out quickly because you just understand how to do everything, but you may also find that you don't. That you have to sit there for a few hours and then take a break and then come back the next day and sit there for another few hours. Give yourself as much time as possible to do this project. It's a huge amount of points, 500 points, which is 5 weeks of lab worth of points, all in one fell swoop. If you don't complete all of the requirements of the project, you can still get partial credit, but the program has to work. So if you submit something that just, I click the run button and nothing happens but errors, you will get a 0. So you want to put time into this. And I'm trying to be dramatic because I get very stressed that there are people out there who are getting a bad result on these projects, and it feels bad for you. It probably worse for you, but it does feel bad for me, and I don't want that to happen to people. So start early. Start today if you possibly can. See how much you can do. Give yourself time to go out and get help on Piazza, to come to my office hour on Thursday, to reach out to me on Canvas Inbox. I've given a couple of screenshots here. Let's see if I blow them up. They're not the bit. Wait, what does this do? I don't know what that is. Anyway, these screenshots are just here to show you what mine looks like when it's running on the screen. And I didn't give you the whole program, just enough to give you a sense of what's supposed to happen. Actually, no, that's the whole program. Anyway, there's the project. Please consider starting it soon. Today, if possible, or whenever you're watching this, whatever today is, not Sunday night, because you don't want to have that feeling of having the first project go badly. Okay, so that's enough for that. I've queued up the lab. I'm going to switch over to Replit now, and I'm going to create one, the Go language. I'm going to call it CSCI 20 week 4. And we're going to explore the arithmetic operators. So you can see it on the agenda that the term operator in programming simply means a symbol that causes some action to take place. So these curly braces, we do not call them operators because they, at least in this context, they don't cause any action to happen. They're just a way that Go has you organize your code. These quotes are not operators because they're really just marking the beginning and endings of strings. So when we say operators, we mean a symbol that causes an operation to happen, and let's do some. So I'm going to get rid of this hello, and I'm going to give myself some variables. X, Y, and Z aren't the best variable names, but we're going to do things that look a lot like algebra. So do I want them to be that way? Sure, that's fine. We'll set up some problems. So there's an X, Y, and a Z, so I can do some math with them. So let's give X a value, and we're going to just start with some little stuff. So what do I want? Like a 3, and I'll say y equals 7, and then we'll explore doing math with these two integers, and we'll do it with just printf. So this is the way I like to explore math, is to make outputs that show me exactly what the computer sees and does. So if I take one integer, space plus space, another integer, space equals space, a third integer, and then I can say, put X in the first slot, Y in the second slot, and then add together X plus Y and make those be the third slot. So it'll be X3 space plus Y7 space equals space 3 plus 7, 10. except for it didn't because I didn't use z. Oh, you dumb go. All right, I'll get rid of z for now. So there is my 3 plus 7 equals 10. I should put a new line at the end. So this operator, x plus y, it's pretty straightforward, right? You take two numbers and what you get is them added together. We could also, so let's put the z back. If we wanted to, we could have said z equals x plus y, and then we could have printed out z in the third slot, which would be the same result. So there's x, which is 3, plus y, which is 7, equals z, which is x plus y, which is 10. Okay, so I want you to notice right off the bat, by the way, that the math part of this line of code is on the right-hand side of the equals, and it has to be on the right-hand side of the equals. So you cannot do this. You cannot put math on the left-hand side of an equal sign. Why? Because it's a rule of Go that you cannot do that. So the way Go works is it will perform the arithmetic on the right-hand side of the equals, the assignment operator. It will get a result, and it will take that result and store it to the thing on the left. So this line right here, Go is going to take the 3 plus the 7, get a 10, and then store that into the z. So one way you might see that referred to sometimes when you're reading about it is we have the is this LHS and RHS. All that's referring to is the left-hand side and the right-hand side. The left-hand side of what? This assignment operator. So there's something to the left of it, which is the z. Sorry, my nose itches. Something to the right of it, which is the x plus y. So the right-hand side is always the math and can never be anywhere else but on the right-hand side. So let's do another one. So let's reuse z. We won't declare another variable, just reuse z, and we will say x minus y. We're using small numbers here because we want to anticipate the answer. So it's a way to check ourselves and see if we understand what's going on. I'm going to take advantage of printf to print the values. Space equals space. So I will print the x and the y and the z so I can see the whole arithmetic and a new line character that Go performs. So it'll give me the value of x in the first slot, which is 3, the value of y in the second slot, which is 7, and then the value of z in the third slot, which, because I did x minus y on this right-hand side and then stored that result to z, should be -4. All right, so all is right with the world so far. And we'll just keep going. So let's do z equals x times y. And some of you, many of you are already figuring this out, so but I'll go ahead and say it this way. When you have information that you can show on the screen, you should do that. And what I'm saying here, I'll give you an example of not doing it next, and then we'll compare the two. So I want to know x and y, and then z, which will be the result of multiplying x times y. Notice that I'm reusing the z. I'm leaving x and y alone and just performing different math, which doesn't affect them. So the result is produced, and then that result is stored in z. So z keeps getting overwritten with the new math. X and y are left alone to their original value. So this one should be 21. So that's good. Now let's do x divided by y. So this is where we have to start thinking, because whole number arithmetic, you may have to think back to probably elementary school for many of you. When you are dividing whole numbers by each other, before you ever learned how to do floating point numbers. So most of you, if I said what's 1 divided by 2 right now, you'd say 0.5, I suspect, anyway. And you have to unlearn that a little bit when you start programming, because the computer does not do 1 divided by 2 equals 0.5. So this is where it's time to start thinking about what divide means. So this is one way to think about it. This is for integers. When we have the divide symbol, what we're really asking is, how many times does y fit into x here? So how many times does 7 fit into 3? Or you could, as another way, you could say, how many 7s? So I'll ask that one too. Or how many y's are in x? How many 7s are in 3? I don't know if anybody in chat has the courage to venture an answer here, but I'll go ahead and give us a couple of seconds of break and ask you, and see if anyone will. How many times does 7 fit into 3? Nice, Shamar. And D-Rose also got it. Yes. 7 fits into 3 0 times. That is integer arithmetic. Nice one, Keller. Actually, it's probably Keller K. So, yes, all of you are correct. Shamar, D-Rose, Keller K. The answer is none times. 3 divided, the whole number 3 divided by 7, in other words, how many times does 7 go into 3, is 0 times. Which is exactly right. That's hugely important to remember. It's also very useful because you could say, for example, how many quarters are in 24 cents? In other words, how many times does 25 fit into 24? 0 times. And then how would you express that in a computer program? You would say 24 divided by 25. We'll do some examples, but you guys are showing up sharp today, so that's good stuff. 3 divided by 7 integers is 0, because 7 doesn't go into 3 any times. All right, so here's the nasty one. That one's kind of nasty too. And you're going to see something funky looking here, which I'll tell you about, and then we'll discuss modulo. So yeah, so I might have gotten ahead of you a little bit in my talking, Shamar. So yeah, so we have the output at the bottom, and it did produces. So the result was actually 0. So yes, if you divide a smaller number by a smaller integer by a larger integer, you will get the result of 0, which is a good question to ask, because these are the ones to really hammer home. Yeah, ask away, because the more times we sort of think about it and find different ways to describe what's happening and confirm that a result is being produced and what is that result, the better. Okay, so now let's do the weird one, the modulo operator. So this is modulo or mod operator. So most programmers will just say the mod operator. Close, Shadow Hunter. So you guys are starting to warm up, which is great. So I'll put the question. I'll try to word a what does it mean, and then see if you guys can come up with the answer. So here's how I would ask the question. That's sort of the non-math way to say it, or the more sort of traditional way would. So modulo is a remainder operator, um, but it confuses people because they don't want to let the quotient go. Um, and we'll do one with a quotient. So 7 is a good guess, but 7 isn't correct. So here we say if I have a 3 and I take all of the 7s out, what's left over? And since we know 0 7s come out of 3, what's left at the end? Nice, Shadow Hunter. It is 3. So 4 is also a good guess, but it is 3. So well, I'm not going to say it in a different way. So thinking back to your earlier schooling years, you might have learned it. This is the way I learned it, if I remember correctly. We would say something like 3 divided by 7 is 0 remainder 3. So that's how I was taught to sort of talk my way through a division problem with integers. 3 divided by 7 is 0 remainder 3. And what modulo gives you is the remainder part. Now, I like to think of it, I find it more useful often to think if I have a 3 and I take all the 7s out of the 3, which is none of them because there aren't any in there, what's left over is that original 3 that I started with. Let's do another problem with it and see how we're feeling about getting the answer. So let's reassign x to be 10 and y to be, let's say 4. And then we will grab our 2. We'll do z equals x. Let's do the divide first. Let me go grab that so I don't have to retype it. Where'd it go? And then we will do the mod. I forgot to tell you something that you're seeing on the screen, by the way. If you see this print before we do the problems, you'll notice that the mod operator is printed as 2 percent signs back to back, but I haven't run it yet, have I? Let's comment the new stuff out and run it. Okay, so 3 mod 7 leaves 3 left over. So mod and divide are related to each other because divide gives you the quotient and mod gives you the remainder of that same problem. So if you need the quotient, you have to use divide, and if you need the remainder, you have to use mod. Now, one thing I forgot to tell you is that notice that there's in the output down here, there's a single percent sign, but in the printf, I put 2% signs, and that's because of the special use of the percent sign. So Go, when it sees a single percent sign, thinks that the next letter is a verb, a D for integers, an S for strings, an F for floats. So a single percent by itself confuses Go, and if you try it, you'll get something weird. So I'm going to change this to try to just print the percent sign by itself, and Go just gets all confused. So to print the percent is actually 2% back to back, and Go understands that a percent followed by a percent means print 1% symbol, which is how you do it if you were doing percentages as well. Here we're trying to show it as the mod operator. Okay. Now let's bring these back and see if we can guess the results. So I'll be patient here because I know that you're lagged a few seconds at least behind me when I'm talking. So let's make x be 10, y be 4, and then make z be the result of doing 10 divided by 4. So we're going to do divide first. And the question will be, what do we expect the result to be on this output? So 10 divided by 4 is what? And it's great to not be shy, because I promise you 99% of everybody is kind of having to learn this stuff basically from the ground up, because you're not in the habit of doing integer arithmetic anymore. Um, 2 is correct. So 10 divided by 4 is 4 goes into 10 twice with some stuff left over, but divide just gives us the quotient part, which is 4 goes into 10 twice. What happens to the quotient? It's lost. I mean, the remainder, it's lost. So that one's 2. Let's run it. I'll comment these out. And we'll run it, and we should get 10 divided by 4 is 2. Perfect. Okay, so Shamar's asking, how am I pulling off this fancy trick? So if you highlight multiple lines and then hold the control key and the /, you can turn commenting on and off. So you can do big swaths of code this way. It turns out that you don't even have, you can do, yeah, it's very useful. You can comment one line, by the way. If you just put the cursor on a line, like my cursor's at the end of line 38, you can control / there, not having highlighted the line. But if you want multiple lines, then you highlight them and you control / to comment and uncomment. Yeah, so the Dan bar has a good way of explaining this. And this is one of the challenges for you, is to explain integer division in the words that make sense to you in your head. So the Dan bar says 10 divided by 4, the result is 4 goes into 10 exactly how many times without going over. So that's a good way to look at it as well. 4 goes into 10 twice without going over is a good way to look at division. Okay, so now who wants to venture a mod of the same problem? So 10 mod 4. And I kind of chose this on purpose because I thought it might confuse you, which maybe was uncool. Shamar is correct, and Shadowhunter and D-Rose are all correct. It is 2. So 10 mod 4 is, so 4 goes into 10 twice with a remainder of 2, and mod gives you that remainder part. Another way of saying that is what's left after you take all the 4s out of 10, which is 2. So here's one of my, here's a place where you can use this in the real world. Keller K also right with 2. So let's do it this way. You get 8 hot dogs. You get 6 buns. How do I compute how many hot dogs I have left over? Mod is correct. Very good. So yes, so D-Rose, mod is correct. The Dan bar also said mod, and that's correct. So that idea of leftover is another way of saying remainder, right? So we'd say bar boo hot dog industry int equals hot dogs divided by buns. I don't know who's to blame for this. I'm gonna make that shorter. So I just, why, I don't know. But let's see. We should have 2. I mean, everybody can do the math, but it is mod. Mod. That is the answer, right? So I figure out how many hot dogs remain after I take out all of those that would have a bun to go with them, which is a modulo problem. So, I mean, we all know I'm going to have 2 buns left over, but that's an application of mod, is that I can figure out how many do I have over. Um, all right, a couple more along these lines, and then we'll move on to something else. So let's do... I don't want to do it with... I don't want to do exactly your project, because then what is the fun for you in that? So let's say... I think I hit caps lock. What? Caps lock. There we go. All right, so here's another one. Let's see how we solve this problem. So I have some amount of soda cans, and I need to figure out how many 6-pack holders do I need to accommodate as many of those cans as possible. And then I also want to figure out how many cans will be left after I've loaded up all the 6-pack holders I can fill. So I want to know how many 6-pack holders can I fill with cans, and then how many cans would be left after I've filled a bunch of 6-pack can holders. Hopefully that makes sense. Nice one, Shadow Hunter. That's exactly right. So I take the amount of just soda cans I have, and I would divide them by 6. So how many 6s are there? Which tells me how many 6-pack holders I need. So we'll print that out. 6-pack holders. And then how many cans would be left over that I could take home for myself, for example. Since I can't fill a 6-pack holder, I'll just take the leftovers home with me. But what would be the math to figure out how many loose cans will be left? You could do it that way. Good one, Shadow Hunter. So there's actually 2 ways to go about this. You could take the total number of cans. So you could say soda cans minus, and then you could do a bigger math and say holders times 6. And or you could say mod 6. So you are going to have some options like this when you're doing arithmetic. So I'm glad that you pointed both of those out, Shadow Hunter. And you use the one that makes the most sense to you. So at this point, I actually would use mod because that's the one I think of first. But that doesn't make it better or worse than this other solution, which is perfectly good, which if it makes more sense to you when you're coding it, you should use. So nice one, Shadow Hunter. You got both of the potential, both of the calculations correct. Let's actually compare them. So these are the ones I'm going to take with me. So, and let's just do it twice. We'll reuse the leftover, and we'll do the math both ways to confirm for ourselves that it is in fact the same result, which it will be, because Shadow Hunter is correct. I don't need that blank line. So we should get the same number of leftovers in both cases. Yep, so there's 3 cans that didn't have a home. Oh, I need 2,057 6-pack holders. And then I'll have 3 spare cans I can take home. And we did it both ways just to prove to ourselves that both of Shadow Hunter's solutions were in fact correct. So there's 3 loose cans at the end that didn't have a 6-pack holder for it. Okay, so there is a whole bunch of just going through integers and thinking about divide and mod. The whole trick to the project is divide and mod. And if you want to employ some variation on the soda cans math as well. So a lot of what the project is about is doing arithmetic, in particular, giving you opportunities to use divide and mod. So you will be asking your questions of yourself like, if I had 99 pennies, how many quarters is that? And once I know how many quarters it is, how do I kind of see what's left after the quarters are dealt with so that I can then figure out how many dimes are in what's left? And then once I deal with the dimes, how do I figure out how many nickels are in what's left? And then finally, after I deal with the nickels, I will have everything that's left must be pennies. So those are the kinds of questions you'll be asking and then writing code to answer on the project. Okay, let's do floating point arithmetic. So we're going to switch gears and talk about floating point arithmetic. Floating point arithmetic is what you're accustomed to doing. So this will be producing results that your mind wants to go to first. The harder one, for most of us when we enter into programming, the harder one is integers because of the weird whole number stuff. Float is the one that you're familiar with. So we'll do a couple. So let's give ourselves some new variables. I will call them A and B and C and make those be float 64. So because they are floats, Go is going to deal with the math with them differently. And let's just do a quick example. So we'll make A equal 1. We'll make B equal 2. And C equal A plus B. And then we will do printf. So we'll use floats this time. And we'll just go out to 1 decimal place on the floats. So that'll be the A spot plus the B spot, space equals space, the C spot, new line character. I'm going to put a separator up here. Just so it's a little bit prettier on the screen. So we'll print out A, we'll print out B, we'll print out C. And these are floats, so we'll do the add first. It's going to do what you expect, which is 1.0 plus 2.0 equals 3.0. So that's as expected. We'll do subtract. So C equals A minus B. I'm going to start being a little bit lazy to not be so slow. And just be careful that I put the minus in there. So A, which is 1, minus B, which is 2, should be negative 1.0. Okay, and you can see that at the bottom here, negative 1.0. We will multiply them. Which should just be 2. Then we will divide them, which is when we will see finally something different. So because they're floats, they're going to behave like you are accustomed to numbers behaving, which is 1.0 divided by 2.0 equals 0.5. So that's as expected. And so floats are going to be the more familiar to you. We will not use the modulo operator with floats because it's not particularly useful to us and it doesn't make a whole lot of sense. And in the Go language, there is a way to calculate the remainder for floats, but we don't do it with the % operator, the mod operator. We do it differently. So what I'm asking you to do in the lab this week is get used to the idea that mod has a particular purpose with integers and that we don't typically use mod with floats at all because the nature of floats is that we already get the extra. We don't lose data when we do floats, but we can lose information when we do integers. Like dividing 10 by 4 gets 2, but there's some information lost there, right? The remainder. And doing 10 mod 4 is 2, but we've lost some information, which in that case is the quotient. With floating point numbers, we don't lose any information when we do division, so we don't mess with the modulo operator and floats in this class. Let's see. So Shamar asks if we want to switch up to put B, C. Yes, that's right. So Shamar is asking in chat, how would we, let's see, which one did you refer to here? Okay, the plus. So how would we change positions for everybody? And that is correct. So if we wanted to say, if we wanted to do A equals C plus B, right? Yep. Or B plus C, then yeah, we'd switch up the, so yeah, all these would switch up. So we'd want to say B, the first slot, plus C equals A. And this is important, Shamar, that you're noting this. So when we display our arithmetic, we tend to put the math on the left because that's what humans are used to. But for us programmers, we know that in our code, we do the math from right to left. But for normal humans, they're accustomed to reading math from left to right, so that's how we display it on the screen. But in code, we always have to work from right to left. So I'm glad that you pointed that out, Shamar. Like, how would we mix up the order of these things? And then how would we show the mixed up order? And this is how you do it. So good observation. And also just important to remember that what we show to our normal people on the other side of the computer screen is not necessarily what we have to do as programmers to make the code work. Yep, so and now we get 2.5, which is quite cool. All right, so with floats, we are not going to do mod because it doesn't make a whole lot of sense most of the time to worry about remainders on floats anyway, because the whole point of using floats is to have all the information and the remainder kind of built into the decimal part. Okay, so there's floats, no mod for floats for us. Now we'll do mixing integers and floats. So the last kind of step here is, what if I want to do a mix of integers and floats? Or what if I wanted to say, what is 3 divided by 7 as a percentage? If these are integers. So if I take my original integers, x, and make it 3, and y, and make it 7, how do we turn that into a percentage? We know that 3 divided by 7 is 0, so that's not going to actually give us the percentage that we want. So this is kind of the last stage of this first introduction to arithmetic, is sometimes we need to get floating point precision from integers. Sometimes we don't care about precision, but we have floats and we want to get rid of the decimal parts. And sometimes we have a mixture of integer and floats that we want to do math on together. So how does that work? So let's look at integers first. So I have 3 divided by 7, but I know that 3 divided by 7 is going to be 0. But let's just see what would happen if I try to use my float c and say x divided by y. So I have on the left hand a float that is supposed to receive the result of dividing two integers. So we will say this integer divided by this integer is equal to this float. So it's the x divided by the y is equal to the float. And let's just see what Go does with that. It won't do anything with it. So Go won't do this, at least not as it appears out of the box. Go will not let me mix floats and integers kind of out of the box. This is important to note. I can't, without taking some extra steps, mix floats and integers and do math with them. But I can use what's called type coercion. So I can actually force the issue. I can coerce Go into treating something as a data type that it isn't. So I want a float result, which means that I need to do float arithmetic. But how do I do that with integers? Well, I coerce them into being floats. I'm going to start just by trying to coerce the x. So the way you coerce an integer into being a float is you put float 64 and then the integer in question in parentheses. That is now a coerced float, which means x, which as an integer is 3, is now the float 3.0. So let's see what Go does now that x has been coerced. It's still complaining because the y is not a float. So there can be no integers in here. Okay, so let's coerce the y as well. And see what happens. Aha! We got a result down here, if you can see it at the bottom. So 3 divided by 7, even though they're integers, I coerced each of them into being a float, and that allowed Go to actually do 3.0 temporarily, divided by 7.0 temporarily, to get 0.4 as a result. Let's put it to 2 decimal places and see if there was more going on than that. There was. I can get 0.43, and it probably even goes out further. So I can coerce integers into being floats. Now let's do it again, and let's try a different technique, because some of you are going to try this. So I want to show it to you, and let's just see what happens and consider what happens. Why can't I just do this instead? Why can't I just say, oh, just coerce the whole darn thing? So let's try, instead of coercing the individual elements, let's coerce the whole darn thing. So let's just take all of it, x divided by y at once, and coerce it into being a float. I got a result, but I got 0. So what's important here is to understand the order in which Go is going to execute things. So when Go sees parentheses like this, it's going to work its way from the inside out. So what Go does with this is it first does this arithmetic, which is the integer x divided by the integer y, which is the integer 3 divided by the integer 7, which is 0. And then it comes out and coerces the 0 into being a float, which is simply 0.0. So watch out for this. This does not work. If you need to mix integers and floats, you need to make sure that you coerce all of the integers, or you will not get the result that you were hoping for. Hopefully that makes sense. I'm going to comment it out because it's not correct, but I want to leave it there as a breadcrumb for you and remind you that you got to coerce all the pieces to get the whole thing to be correct. So it's correct to coerce the x and also coerce the y, and then divide the two coerced to be float values to get a float result. What about going the other way? What happens if I take the a and make it 1.1, and the b and make it 2.2, and then try to add those together into an integer z. So I think you know probably what to expect. So we take a float and we add it to another float to get an integer. So we have the a float and the b float to get the z result, which is an integer. What we'll go do with that? It won't do it. Same reason. It will not let you mix floats and integers in math. So maybe we can go the other way. Can we coerce a float to be an integer and another float to be an integer? And what does it mean to coerce 1.1 to be an integer and 2.2 to be an integer? Let's find out. Okay, so it did it, and notice that the result is 3. So if you coerce a float into an integer, you drop all the stuff after the decimal point. Sometimes it actually works out that that's handy to do. Yeah, so that's a good way to say it, Shamar. So Shamar in chat says what coercing a float into an integer does effectively is rounds it down, and that's true. That's exactly correct. Can you round up? You can. I can show you, but let's say we have 1.9 and 2.9, and see if anything is different about the coercion. All right, so same result. So it's going to chop that dot stuff off. So yeah, be careful. So rounding down does work, but you have to realize that it won't do any rounding up. It's going to just chop off everything after the dot. And yeah, the Dambar says coercing a float removes everything after the decimal, and that's correct. So you lose everything after the decimal, and sometimes that's actually a useful thing to know how to do. But Shamar asks, is there a way to actually do a rounding up? And there is a way to do a rounding up, which I can show you real quick, and we will use it soon. So there's another, so I'll go ahead and do it. To actually round a float up requires an extra library. So we go up and we add math to our imports. I'm pretty sure it's in math. And I'll be posting this code sample. So now we will do, so the way we do this is we'd say C equals math dot, I think it's seal probably for sealing, A, and let's see what happens. And I'll be kind of fancy about it and say, man, I'll put the value actually in there for the output equals F. So we will take the A applied to sealing, and let's see what it does with it. So this sealing is how you do a rounding up on a float. So math.round has the behavior. So DeRose Artist asks, so what does math.round do? So math.round does the familiar kind of rounding. Let's try it though. So let's see what happens if we make A be 1.5, and then we do C equals math.round A, and then I'm going to sort of hasten this a little bit. So this is bonus material, but you do want to understand how to manipulate these values. So let's do round to it instead this time and see what 1.5 rounds to. So 1.5 rounded to 2. What is 1.4 round to? And 1.4 rounds to 1. So the rounding has that behavior that you're probably familiar with. I'll go ahead and give you the funsy one last one, which is, so you have a ceiling, which takes it up. You have the rounding, which has the behavior that 0.5 goes up and 0.4 goes down. And then you also have floor, let's try it on 1.9 and see what that does. You can actually floor a float, which smushes it down no matter where it's at. So ceiling goes to the next one up, guaranteed. Floor goes to the next one down, guaranteed. And then rounding has the behavior that 0.4 is down and 0.5 is up. Which those are handy operations, and we will be using those in this class. So it's not really bonus material. It's a preview of things that we will do coming up. So I will make a note here that math provides some functions to manipulate floats. And then we have that. So round, seal, and floor, all of which can be handy, in addition to the coercing, which has its own behavior. So that's all of the maths. What else was I going to... Yeah, so let's go look at the lab. We're good on time. We're doing great on time, actually. We'll look at the lab, and then we will look at where we're at with the project, and then we should be done, I think. So let's look at the lab and see what it is asking us to do. So I'm going to go grab the code, and then I'll paste it into a... made a mistake there. Let me make a new REPL, and I will paste that stuff. There we go. So this will be a Go REPL. This will be CSCI 20 Lab 4. So I'll post everything that I just did, and I'm probably not going to be posting anything else. I'm not sure why this is taking so long. There it goes. Okay, so let's paste in the lab code and see what it is asking of us. Okay, so documentation. Come on, man. Okay, documentation as always. So we're going to do a string variable to hold a user's name. And then notice that this number one instruction is combining multiple operations. So I'm kind of shifting the instructions with the expectation that you know the sequence now. So if I need the user's name, what's the sequence? I need a variable to hold their name. I need a prompt that requests them to type in their name. And then I need a scanf that will read in the name. So that number one is that sequence of setting up for, prompting for, and reading or scanning their name. Number two is simply using their name to say hello to them. So hello, Boyd, that's what you just typed in. Step three is several things happening at once. So we need to prompt for and read in two integers here, right? So we need two integer variables, and then we need a prompt that says, please enter a number, scan that number. And then we need another prompt, please enter another number, scan that number. So it says prompt for and read in values for both two. Yeah, right? So this is our X and our Y that the user is going to type in. So instead of hard coding numbers into the program this time, we're going to let the user type in numbers. And you know how to do that. It's just that we're going to do something slightly different with the numbers. So here we'll have a formatted printing. Oh, you entered 3 and 7, or whatever it is they typed in, right? You will use their variables in your output to say, here's the two numbers you entered. And then you're going to go into a sequence where you do math with it. So you're going to say 3 plus 7 equals 10. Whatever the numbers are, right? You don't know the numbers. You have to use the variables. So your X value minus your Y value equals this. Multiplied, divided, modded. If you want, it doesn't tell you to create a third variable, but you may create a third variable to do the calculation into, kind of like our Z, right? So the X would be a user entered number, the Y would be a user entered number, and you can add another variable for yourself, a Z variable, so that you can do the math like we did it in the samples today. So that's the difference between what I did in lecture today and what you will do on lab is I coded values into my program, you will have the user typing them in. So it's going to feel funny at first because you don't know what values your user might type in, which means you have to write a program that's going to work against unknown specific values based entirely just on variables. So it's fun to do, and it's very interesting. Like, oh, that's awesome. Like, I typed in those numbers and the program just took them and did math and showed me the results. Pretty cool stuff. So notice for the two integer variables, plus, minus, times, divide, and mod for those two variables. And then we get into part 2. So part 2 is using floats. So you will declare 2 floats. You will prompt for the first float and scan it. Prompt for the second float and scan it. Then you will print a message saying, here's the 2 values that you entered using the variables that you scanned into, right? And then the last part is to do the math. And if you want to, you can declare a C variable like we did in our sample today, but you don't necessarily have to, but you may. But you're just going to do plus, minus, times, and divide on the floats because remember, we're not going to do mod on floats in this class. And I've even put a note in here that you will not do that. That's the whole lab. And with that knowledge, you can do the project. So that's all I'm going to do in terms of the lab is I'm going to start leaving you to fill in the blanks with your prior experience. So don't forget on the lab, you have Piazza, you have Thursday office hours, you have Canvas inbox if you need help. Now let's go look at the project and then we will be done probably a little bit early today. Not there. Let's go to my REPL where I had started the project and let's revisit where I was at and see what we can do now. Here's my project 1 REPL. I should probably, I'll do that later. So let's see where we left off. I put a welcome message. I prompt for and read in amount of quarters. After last week, I could do that for all of these quantities. And then I will print out a confirmation like, okay, you have 3 quarters and 2 dimes and 4 nickels and 7 pennies. Then you do the math. So the math is pretty straightforward. You're going to have to use variables. So if you're going to have to take the number of quarters, which is this variable here, and multiply it by 25 to know how many pennies that is. And then the dimes variable that you get by scanning times 10, the nickels variable times 5, and then the pennies variable. And if you add all those up together, you get what that is as a big bag of pennies, right? And then we have part 2, which is the penny reducer, which is the more challenging part, in my opinion. You're going to prompt for and read in. So this is like a separate program. So don't think of it as connected to the first part. Think of it as another program that's being presented in the confines of this one application. So, all right, now I have the penny reducer. How does that work? You have to ask your user another question. How many pennies do you got? So you're kind of thinking of this as a separate program. And your user is going to say, I have 782,000 pennies, or whatever they type. Let's say 782 pennies, completely unrelated to what happened in part 1. So now you have to take that 702 pennies and say how many quarters fits in there. And now I have to take the quarters out and say how many dimes fits in there. Maybe I should give you some hints on this. I'm not sure. In fact, we will get some help from the people who are here on the live stream. So those of you watching the video later, make sure that you figure out some way to extend your thanks to the live stream participants who are about to help us with some hints. So I'm going to need bag of pennies to be an integer, and then I'm going to say, how many pennies do you have? And then I'm going to have to scan that in. Don't forget the ampersand. There's my bag of pennies. We can reuse variables from above. So if we have up here, for example, dimes and a nickels and so on, we can reuse these variables if we want to. I'm putting the dimes one here because I think I may not need it for the sample that I want to do. So let's just start with this. Okay, so chat. How many quarters are in my bag of pennies? As your gift to your... That's hilarious. Maybe. So Shamar said 4,203, which is hilarious. Yes. So the answer is, well, if I take my bag of pennies, then I need to know how many quarters are in there, which is what that means, right? So if you divide bag of pennies by 25, that's how many quarters are in there. So now something has to happen. So now, how do I take the quarters out? So I need to do something to my bag of pennies because I need to get all those 20 little piles of 25 pennies out of there. Mod, Shamar, is correct. So I take that original bag of pennies and I do mod 25. DeRose, you're close. It's mod 25 to get what's left. So there are other ways to do this, but this is kind of the most obvious way to do it. I have to figure out how many quarters are in there first, so I can count out quarters. And then the second step is I got to see what's left after I've counted out the quarters, which is where mod comes in. So this first line tells me, oh, there's that many quarters in that bag of pennies. This line says, okay, now I got to go into that bag of pennies and actually count out the little stacks of 25 until I can't take any more whole stacks of 25 out. Now I do dimes and so forth. So this right here. So there's the hint. And thank you to people who are here participating in chat for offering the helpful hints to your classmates. And it takes courage to offer an answer that you're not sure if it's correct. But that also means that you're just a human being. If you don't get the correct answer 100% of the time, then you are a human being like all of us are. So the special thing is to have the courage to venture the answer in search of the correct answer. So very much thanks to all of you in chat today for being willing to participate that way and venture what sometimes might be a wrong answer in search of the right one, which was a very great contribution to make. And hopefully in the process helped you kind of clear up some of your thinking around it as well. So thanks to all of you for doing that. Yeah, D Rose says in chat that they really like this mod operator. It's really cool. It is super cool. We don't need it for the project or the lab, but you can use mod to figure out what numbers are even numbers, just as an example. There is a way to use mod to discover whether or not you have an even number, which is kind of cool, which is just kind of a different word problem around the use of mod. Okay, so there's hints. These are screen-only hints. This is not a project I'm going to share, so I'm going to leave this here for a minute or two and talk over it. But these hints are for video only. So that's true, Shamar. So Shamar shared a Bill Gates quote saying, I will always hire a lazy person because a lazy person will find an easier way to do things. That's a good point. Of course, what's implied underneath there is it is a lazy person who has some skills and knowledge. So it's a useful combination. A person who has skills and knowledge, who doesn't want to make a complicated solution where one doesn't need to be. Very nice. Okay, so hopefully that's enough time to see these hints about the first project. I will upload the other sample with all of the math in it, with the floor and round and seal stuff, and also the examples of the integer and float math. Same thing for the project as the lab. Piazza. If in doubt in Piazza, just venture your question or your answer with code in it, and I will weigh in and offer correction. So if you're in Piazza, you are safe for seeking help and offering help, because if you're asking for too much or giving too much help, I will simply offer correction, and then we will all kind of learn together what's the appropriate amount of help without kind of spilling over into I'm just giving this person the entire solution. So Piazza's safe, and I will be checking it frequently. So that's a good place to go for lab or project help. Canvas inbox, of course, and also office hours, also available for this your week with your deadline on your first project. So best of luck on those things. My dream is to grade 60 perfect ones, which is the best possible outcome for me, and hopefully you think that as well. So yes, Shamar, actually I'll go show you that. So Shamar is asking in chat, do we have a place to go put questions and comments about projects or labs in Piazza? And there is. So I'll pull up one of the sections. So there's this open forum folder here, and in there are actually lab project homework places to go put posts. If you just do a new post and you hang it out there in space, don't worry about that. I can relocate it to where it needs to be. But this open forum folder will let you actually locate your questions and comments specific to lab project homework or miscellaneous stuff in there. So, and both sections have that if you want to use it. Okay, very good questions. I'll wait around for another couple of seconds, put this back on the screen. This is a project 1 tip. I will wait for maybe a minute, 2 or more, just because I know there's a lag between me saying this and you hearing it. So I'll wait around for a minute or 2 more and see if there's any questions. Otherwise, I hope you have a great week. I hope that you'll run through the lab and the project go well for you. I hope that if you need help, you seek it, because you will get it. And otherwise, I will see you on Tuesday next week. So I'm going to sit here quietly for a moment and then go into the stream is over screen.